Welcome, everybody. We are live, and welcome to today's grand finale of STARCON. At 20 o'clock UTC, we're going to be doing the return of Trivia Dungeon. But first, we have an amazingly special session for you. And joining me today is none other than the truly legendary veteran of X Team, Mr. Michał Kowalec. How are you, sir?
Very fine, thank you.
Oh, well, that is always good to hear. Let me actually boost you up again. Cool. Now, where are you actually coming from today? Are you in Poznan or Warsaw these days?
Yeah, I'm in Poznan these days. Been there for a couple of years now. Yeah, I really like the city.
I miss it. I always miss it. But hey, we don't have time for small talk. We need to get every minute of greatness out of this. We have some amazing questions that have already come in. But we are joined today by another legend, Dr. Avi Loeb. Dr. Loeb works at Harvard University, is formerly the longest-serving chair of the Department of Astronomy there. He also founded Harvard's Black Hole Initiative, which is actually the first center in the world, believe it or not, to focus on black holes entirely. Time Magazine, we'll see what he thinks about this. Time Magazine called him one of the most influential people in space. It is an honor today to welcome Dr. Loeb. Hello, sir. Welcome.
Thanks for having me. It's a great pleasure.
How does it feel to be Time Magazine's most influential people in space?
Well, it's nothing that particularly impresses me. I'm just a farm boy. I was born on a farm and haven't changed much since then. And I acquired some labels since then, but they don't matter so much. I'm still maintaining my childhood curiosity.
Well, that is what STARCON, this event we are hosting, is all about. It is about tapping into that curiosity, staying forever curious. I love hearing that you are still keeping that alive with all the work you do. Thank you for all the work you do, by the way. Where are you joining us from today? Are you in Massachusetts?
Yes, near Boston. I live in a suburb, and that's where I've been since the pandemic started. I'm jogging every morning at 5 a.m. in the company of birds, ducks, and wild turkeys and rabbits, and I enjoy it very much. It has been the most productive period in my career.
That is actually almost a controversial thing to say, because I agree. It has been probably the most productive year, despite being the most tragic time in history that we've been a part of. So interesting. But hey, if anyone has a question today for Dr. Loeb, please, you can drop it in the chat. If you're watching on YouTube or LinkedIn, we have questions coming from X-Teamers who have already submitted their questions. But if there's time, we'll definitely pick up some extra questions from the chat. So Michał, you're going to be moderating us today. Please kick off. Let's learn about the mysteries of the universe.
Thank you. It's great to have you here, Dr. Loeb. And so we have a number of questions from X-Teamers who have submitted them in advance. So we'll go through them and then pick up any questions from the audience, or if there are any relevant questions from the audience to the questions that we are talking about, then we'll do it at that time. So the first question from Thomas is that given the extreme distance in space and time, even to Alpha Centauri, how likely do you think it is we will ever be able to leave the solar system?
So I'm working on a project, in May 2015, a black limousine parked in front of the Center for Astrophysics at Harvard, and out of it came an entrepreneur from Silicon Valley named Yuri Milner. He came to my office and asked me to lead a project to visit the nearest star within his lifetime. He's the same age as I am, and that meant within a couple of decades. And of course, that looked like a very challenging proposition because it meant since the nearest star is 4 light years away, just leaving the solar system and going there would mean that you need a spacecraft that travels at a fifth of the speed of light if you want to get there in 2 decades. And that is 1,000 times faster than any rocket, chemical rocket that we have previously used, like New Horizons or or Voyager. So I told him I need to think about it, and then came up after 6 months with a concept of a light sail pushed by a very powerful laser. So that seems to be a possibility. We are working on the technology now. It's called the Breakthrough Starshot Initiative, and I'm leading the advisory board for that. I would not be very optimistic that it will happen within the next decade, but we're starting the first steps in the direction of making it feasible. Other than that, if we were to use chemical rockets, it would take us 50,000 years to reach the nearest star. So we should have launched it when the first humans left Africa in order for us to get there today. So that's a long time. We can't really wait that long. That's what leads me to the proposition that, if we ever have contact with another civilization, it will most likely be in the form of equipment, a system or probes that are visiting us, perhaps artificial intelligence, much more sophisticated than we have right now, but it will very unlikely be a biological creature that we have to shake hands with.
On that exact note, what is your take on the theory of the great filter? So is there an actual universal event that prevents civilization from ascending to the galactic level and us probably not meeting any of those civilizations yet?
Yeah, so if you look at the way we behave, we are not particularly careful about keeping our environment pristine, and we often engage in conflicts. So it's quite possible that we would survive only a few more centuries because we had 1 century of technological advance and we are already modifying our environment. So that would argue that there is a short window of opportunity to find a civilization like ours. And in addition, you have to keep in mind that most of the stars formed billions of years before the sun. And so that means that they predated us long before we came to exist. And if there was a technological civilization similar to ours that was able to survive many centuries, they developed technologies or equipment that would look like magic to us. It would look like an approximation to God as far as we're concerned. And therefore, I wouldn't be surprised if the galaxy is full of probes, of equipment that was sent by a more advanced civilization, simply because if they had 1 billion years, that's a long time to spread throughout the galaxy. And you can actually send probes that will replicate themselves if they're equipped with 3D printers by going to places like another planet and using the raw materials there and making copies of themselves. And that's called von Neumann probes. He thought originally about it. So just think about systems that are equipped with artificial intelligence. They can learn from experience. They can use machine learning. They are more intelligent than you, could potentially be smarter than we are. If we ever encounter them, and the UAP report that came that was brought to the attention of Congress may mean that we are encountering them. We might need to use our own AI systems to interpret what they're doing. It's just like relying on kids to tell you, to interpret for you the content on the internet simply because they're more skilled with computers. So we will use our computers to figure out their computers, so to speak.
Mm-hmm. And which one is more frightening to you, that we are alone in the universe or that we are not?
That we are alone, because that's a great responsibility. It means that we have, to be careful at what we do. Currently, all our eggs are in one basket here on Earth, and it would make sense to spread them so that we will not be eliminated by a single point catastrophe. And so as a result, it's a great responsibility for us to do the right thing and spread into space and make copies of what we find precious here on Earth elsewhere. If there are others, if there is a smarter kid on the block, we are not that precious. I would feel relieved, actually, in a way, because we could learn from that smarter kid, and
hopefully.
And in fact, I would worry about the smarter kid maintaining its longevity, and because after all, I think in the long term, if you think about Darwinian selection, what matters is intelligence, because it's not about the physical strength. The dinosaurs, if you think about it, they had huge bodies and they dominated their environment, and they felt quite arrogant until a big rock 66 million years ago, the size of Manhattan Island, fell from the sky and tarnished their ego trip abruptly. And so that is an important lesson, that physical strength is not really what matters. In the case of humans, we have much smaller bodies than the dinosaurs, but we have the human brain that allows us to construct telescopes. And from using them, we can get a warning about a big rock approaching us. and deflect its trajectory such that it will not hit us. It just shows you that for survival, intelligence matters.
Might be a good follow-up here, actually, Michal.
Yeah, exactly. There's a question from Artyom in the chat.
Yeah.
And he asked do you think if we are alone, is this because other civilizations have already existed and gone? Or is this because we are the first civilization in our neighborhood?
Oh, no. What I would say is, if there were, it's quite likely that there were civilizations that predated us by billions of years, because most of the stars formed billions of years before the sun, and we now know that about half of the sun-like stars have a planet the size of the Earth, roughly at the same separation. So the physical conditions on Earth are not by any chance special or unique or privileged. What we find in our backyard is very common. There are tens of billions of similar systems, Earth-Sun systems, in the Milky Way galaxy alone. And then there are trillions of galaxies like the Milky Way in the observable volume of the universe. So, humans, of course, at first thought that, we are special, we are at the center of the world. And that's just like my daughters thought that when they were young, when they were at home, they thought that they are the smartest, they're the center of the world. Then we brought them to the kindergarten and they met other kids and they got a better perspective. And, one way for humanity to mature is to meet others. But what I can tell you is already we know that we are not at the center of the stage, that the play is not about us, because we know that there are many other systems similar to the Earth and the Sun. And then when you think about the fact that most of these stars formed before the Sun, to me that implies that if you arrange for similar circumstances, you might as well get similar outcomes. And many things like us existed before us. Okay, and just like ants on a sidewalk. And then if they developed a few centuries into our future, and they sent AI systems with 3D printers that can replicate themselves, the galaxy could be full of those probes. And I wouldn't be surprised if they arrived here. So even if those civilizations, the senders, are not around, one thing that you have to keep in mind when you have an autonomous AI system, it doesn't want to communicate with the senders because the nearest star is 4 light years away. If you want to communicate with a sender on a star sort of at the edge of the galaxy, it takes tens of thousands of years for light to traverse that distance. And nobody has patience to wait for a return signal that takes 10,000 years to come back. And therefore, such a system would be autonomous. It will operate based on its own intelligence, of course, following the blueprint that it was assigned. So whoever sent it provided it with some blueprint that is aiming to achieve some purpose, right? But it would not communicate with the sender, and therefore, if the sender is dead, if there is nobody there, if you send a mail, you go to the post office, send some envelope. You can, it's possible that you will die afterwards, but the letter will still make its way. So the point is, this equipment that was spread by others, maybe billions of years ago, will continue to work. There is it has nothing to do with whether the civilizations that sent it is around anymore.
Yes, makes sense. Like the light that we're shining now takes a long time to travel. And we have one last question from Cleo on the subject of extraterrestrial life. He has a theory that the Kardashev scale measures the advancements in civilization based on how much energy it consumes. But what if more advanced civilizations are actually limiting their resource usage so that they do not consume all the resources that are around them so quickly. And this is the reason why we haven't met any civilization, because advanced civilizations are actually not interested in our resources.
Well, during the pandemic, I had this idea that, in fact, other civilizations that are very advanced would not be interested in communication with lesser civilizations because it would degrade their lifestyle. So I called it social distancing on a cosmic scale. That doesn't mean that we will never find anything about them, because they would still have to throw out trash. And like these investigative journalists in Hollywood, we can go through their trash and figure out what they do on their daily routines, and but the other thing to keep in mind is that that communication will not be directly with them. It will be with whatever they sent out, and therefore their whereabouts is not really what matters. When you do space archaeology, that's what I call it, when you look for relics that they sent.
So let's go back to our own backyard of the solar system. I think Beto has a very good question to start, which is, why are we so interested in Mars? Is there a special value that it has for us humans?
No, it's simply that Mars and now Venus, there were now 2 missions announced recently to go to Venus after it was neglected for a long while. Actually, the Russians were the ones that investigated Venus decades ago, and NASA for some reason didn't like it because it's sort of a hellish environment. It went through a greenhouse effect, so the ground on Venus is too hot to have any liquid water there. It's a very different planet than Mars, but what's common to Earth, Venus, and Mars is that they are all roughly within the sort of habitable zone around the sun, meaning in principle, depending on the conditions in their atmosphere, they could have had life or may have still life. So that there are 3 planets in the solar system that are just around the distance where liquid water may have existed at some point in their history, and therefore the chemistry of life as we know it could have taken place. Earth is one, and by the way, Earth is a little bit outside the optimal habitable zone, so it went through ice ages. It's a little bit colder than it should be.
We're helping it now.
Well, now we're heating it up, yes. But there were long periods of time, like hundreds of millions of years, where the Earth was frozen, like a ball of ice. We tend to forget that. Anyway, so the Earth is not perfectly in the right place, but it is, as we know, we can live on it. And then you have Mars that is 10 times less massive than Earth, and that's a very important physical fact about it, because what happened was on early Mars, there was an atmosphere just like the Earth has. And by the way, to have liquid water, it's not enough for the surface temperature to be the right one, because if it's too cold, it will freeze. If it's too hot, it will boil off. But you need also to have external pressure, an atmosphere, because otherwise, if you take water, ice, and just warm it up in vacuum, it goes straight into gas. So what you need is the phase diagram of water says you need an external pressure to get liquid water and the chemistry of life. So that means you need an atmosphere. And what happened on Mars is because it doesn't have a strong gravity on its surface as the Earth does, it lost its atmosphere. So there was an atmosphere early on. There was probably liquid water. We see evidence for that there were lakes or rivers on its surface. So very likely there was probably life similar to early Earth on Mars. And that's what attracts our attention, to try and see if indeed. And by the way, there are rocks that came from Mars to Earth. We found one that actually was not heated by more than 40 degrees. And if there was life on early Mars, it could have delivered it to Earth, because it was never, the microbes that may have been buried deep inside that rock that was found a couple of decades ago could have survived the journey. If you had small mini astronaut like microbes inside the rock, they could have come.
Super interesting. So how was it possible for that rock to actually land without getting heated?
Well, first of all, how is it possible to launch it? That's an interesting question. And of course, if a rock hits the surface of Mars, it can cause what is called spallation, where you basically lift a surface layer from Mars in a very gentle way so as to eject a rock that doesn't get heated much by that process. And so that is possible. And then once the rock is in space, then it has some chance of colliding with Earth. So obviously you launch many rocks before one of them goes to Earth, because the chance is small. but we have examples of those. And then when it enters the Earth, the atmosphere, if it's large enough, it doesn't burn up. It's like a meteor. Only the surface layer, if it's larger than the size of a person, only the surface layer gets very heated through the friction with the atmosphere, but the inner core of this rock may not be heated much. And again, when it lands, similarly, it depends on exactly how it lands, at which angle. But apparently this rock, it was demonstrated, was not heated by more than 40 degrees Celsius. So life could have survived in it. And in principle, we could all be Martians. If life was brought to Earth from Mars and then started here, we're all Martians. So that's why it's fascinating. But then in Venus, the situation is quite different. You couldn't have had life on the surface for a long time because it's too hot. But 50 kilometers above the surface, there is a cloud layer that has roughly the same conditions as in the lower atmosphere of Earth. And therefore, microbes could survive in droplets there. And there was a recent report that perhaps there is some gas called phosphine that may have originated from microbes in that cloud layer, 50 kilometers above ground. So the missions that were announced recently to visit Venus are aimed at figuring out, maybe scooping some material from the clouds, trying to figure out if there are any microbes in the clouds of Venus. By the way, did you ever wonder why the sky is not green? Why don't we have life in the clouds?
There's too little water. The water is probably
No, we have water vapor, right? That's why we get rain. The water is not the issue. Why isn't the sky green?
Tell us.
Tell us. Yeah.
It's because of the UV radiation. It's actually not the ultraviolet radiation coming from the sun. The conditions are not appropriate for life to survive up there, actually. But it's an interesting question.
Yeah.
There was a guess that it was gravity. Nope, not gravity.
No, not gravity. No, I mean, you get rain and the droplets do fall back down. In principle, it could have been that life could have existed in those
would such
droplets.
conditions be possible in other planets that are more further from the sun?
So in other planets, you could have a green atmosphere. Yes, I actually wrote a paper about that. In particular, for very low mass stars, you could have life in their atmospheres. Yeah, because the temperature is just the right one to allow, in principle, life. Yeah.
And would it be possible in gas giants, maybe deeper inside their atmosphere?
Yeah, except they're not made of. They don't have liquid water there, so it's often thought that to have liquid water or droplets, you need a rocky surface. That you can have an atmosphere above the rocky surface, but you really need a rocky surface. But it's a good question. I mean, this is to be found. Maybe there are some giants where life is possible.
And
as Austin reminds us, some people for sure are coming from Mars.
Well, I can only say that my wife said that sometimes I sound a little weird to her. So if they ever come to pick me up on a spaceship, she asked me to do two things. First, to leave the car keys with her, and then to make sure that they don't ruin the loan when they take off.
Nice.
So
by the way, I should tell you that in my class, I asked my students whether they would take a trip if a spaceship came over, and all of them said yes, but with one condition, that they will be able to share their experience on social media, which to me was a real surprise.
Yeah, I was expecting the condition to be a trip back, but
no, they didn't care about that. They just cared about sharing it.
Nice. And Stuart was wondering, because Saturn was the first planet that he saw through a telescope, and he heard that there are oscillations in the magnetosphere that are close in a rate to the rate of rotation of Saturn. And so do you know if those things are related? Are the clouds rotating at the same rate as the magnetosphere?
Well, it's possible that there is some kind of a resonance that makes provides a reinforcement, a force that keeps them in sort of co-rotation. I haven't studied this particular environment.
So I think we can now go to our section about theories and
This is where it gets interesting.
yes, going far into the unknown. So maybe let's start with Jonathan in the chat. Is there any possibility that parallel universes or so-called alternative dimensions exist?
Right. Of course, there is a possibility. The problem I have with these ideas is that, well, there was no experimental test as of yet proposed that can actually prove them wrong or right. And in general, I do think that it's an essential component of science that you can test ideas, because otherwise it's metaphysics, philosophy, or religion. If you can't really provide an experimental test that will rule out the idea. The other way I put it is, Bernie Madoff had a beautiful idea. He said, give me your money and I will make more of it, irrespective of what the stock market does. And people loved this idea, gave him their money. And obviously, they were very happy giving him their money. He was very happy that they gave him their money. Everyone was happy. What was the problem with this idea, if everyone is happy? The problem was when they wanted to do an experimental test. They said, give us the money back. And then he couldn't do it. So he was put in jail. Now, this shows you that testing your ideas, I mean, the idea can be beautiful. Everyone can be happy. No problem with that. I have no issue with people being happy. The issue is this idea a correct description of reality? And how do you find out? By an experiment. And the point is to recognize that science is not a monologue. It's not that you say something about nature. Nature has extra dimensions. There is a multiverse. Wow, that's an amazing idea. That's not what science is about, an idea being amazing. Aristotle said, we are at the center of the universe. Everyone was happy because it flattered their ego to be at the center of the universe. It was a beautiful idea. You had spheres centered on us. For 1,000 years, people believed him. Then came Copernicus. You're from Poland. You should be proud of Copernicus. Yeah. And Galileo. And through observations, argued, no, actually the Earth moves around the sun. What was the response to that? They put Galileo in house arrest, and the philosophers refused to look through his telescope. Now, what did they achieve? Well, they achieved that they could maintain their ignorance for a little longer, but the Earth continued to move around the sun. So here is my point. We can all talk about things that we can never observe. There is actually a statement in ancient Judaism that says, if you want to lie, you keep your evidence far away. And there is a lot of truth to that. So all of these ideas about extra dimensions, the multiverse, the landscape of string theory, they're beautiful ideas. They are a very good sandbox for demonstrating that you are smart. But that's not the purpose of science. The purpose of science is to figure out something true about reality. And the way to do that is through experimental testing of your ideas. And that's the issue I have with that. And as far as I'm concerned, maybe these ideas are true, but as long as you can't test them, it's not science. It should be the periphery of science. Yep. And mathematical sophistication is not really the key. It's not about showing that we are smart. It's not about us.
Yeah, that's a very good answer. And talking about things we can't measure, in your best estimate, what about the dark energy? What will it turn out to be something, or same for dark matter? Is this just an artifact in our model, or is this a real thing?
Right. So let me first explain what these concepts mean. So the dark energy is simply the energy density of the vacuum. So if you take a volume and you clear out all the matter, you are left with a vacuum, nothing, no matter. You might think that it's an empty space, but in quantum mechanics, space could be full of energy density. And in fact, in the simplest model, it's just a constant of nature. So the vacuum mass density or energy density is the same everywhere and it's constant in time. That's in the simplest model. And that is called the cosmological constant that Einstein conceived back when he came up with the general theory of relativity. He wanted, I mean, it turns out that if you have some energy to the vacuum, it produces a repulsive gravitational force. So in principle, Einstein thought maybe the universe doesn't expand. So you can balance the attractive force of gravity on average by this repulsive force of the vacuum. And he thought maybe that's our universe, because it was much more appealing to him to have a static universe that doesn't expand. Mm-hmm. But then, as we say, some ideas are beautiful but are wrong, as we said before. So Einstein indeed realized that he was wrong, because Edwin Hubble and others, Lemaitre, they found the universe is expanding. So if the universe is expanding, you can't have this balance. And besides, it's an unstable balance that if you perturb it a little bit, you either collapse or you expand. So then, nevertheless, we came back to this idea of the cosmological constant, because it was realized about 2 decades ago that the universe is not just expanding, but its expansion is accelerating in time. And the only way to get that is if the vacuum is giving an extra push to the galaxies that are receding from each other. And that is the repulsive force that keeps pushing things apart faster and faster. That's the accelerating universe. So we now know that there is some cosmological constant, and people call it dark energy. It's just a different name. And in the simplest model that is consistent with all the data that we have, it's constant, doesn't change. The same everywhere, the same at all times. Now, at early times in the universe, it didn't really matter because the value is constant. So if you go back in time, the universe was denser. Matter was much denser. So matter dominated. Also, the radiation had a larger energy. As you go back in time, it dominated. But as the universe expanded, they got rarefied. And at some point, the vacuum exceeded the mass density of matter. And that's where it started to cause an accelerated expansion. So we now know that it happened recently, but nobody understands where it's coming from. Why does the vacuum have this particular value of the mass density? And it may well be a constant of nature, just like the electron has some mass. We still do not fully understand why the electron has this mass, why the proton has another mass. But we call it a constant of nature. Why does the speed of light have this value? We don't know. But my point is, it could be just like all these constants. We can just think of it as the vacuum energy density being a constant of nature. But if you want to understand at the fundamental level where it's coming from, why this value and not a different value, that's a very challenging question that we have no idea about. Some people suggest, those people that talk about the string theory landscape, again, a theoretical construct that we have no test of, they say, the vacuum can have many different values of its energy density, actually 10 to the power 200, a lot of values. And most of these values have very high energy densities. We wouldn't exist in those regions. That life would not be possible because the universe would be expanding like crazy. And galaxies like the Milky Way would never form. We would never exist. Therefore, we exist in a region where the cosmological constant is small enough, the vacuum density is small enough for us to exist. I mean, that's one explanation, but I don't find it satisfying because it doesn't make a prediction that we can test. Anyway, so that's about the dark energy. And indeed, it could be that there is a fundamental reason. It's still unknown, to physicists. Now, the dark matter is a different issue. We recognize that most of the matter in the universe is dark in the sense that it doesn't interact with light. But we see evidence for it because it still gravitates. It produces a force of gravity. And what we can tell is that there is much more mass out there producing a force of gravity than visible matter, the matter that we are made of. And so the question is, what is that matter? And it could be just other types of particles that interact very weakly with light. For example, neutrinos are a type of particle, that they interact very weakly with light, but they cannot make the dark matter. We now know that. So it's a puzzle. What is the dark matter? And, for the past 40 years, we've been searching for different types of dark matter. People said, oh, maybe it's weakly interacting massive particles. Maybe it's axions. And we invested hundreds of millions of dollars searching in the dark, and we haven't found it yet. It's one of those puzzles that is still open.
Do
So
you have a personal
it's also,
favorite?
sorry?
Do you have a personal favorite as to what the explanation is?
No, actually, I should tell you that and I wrote a Scientific American article about it a month ago. To me, the fundamental question is, are we missing matter, or are we not using the correct law of gravity? See, that is a more fundamental question, because we are inferring the existence of this matter by using Einstein's theory of gravity, but perhaps that is wrong, and there is no missing matter. It's just a different law of gravity. So we don't know it until we find it. We will not know what it is. And I'm actually right now I'm writing a paper with a postdoc of mine that provides new clues about the nature of dark matter. It's still an open puzzle. One thing I should tell you, an anecdote, that over the years I suggested all kinds of insights into the nature of dark matter, and some of these ideas were completely speculative, like the dark matter particles may have a small charge, electric charge, or they may have some collision cross-section with each other. These I regarded as speculative ideas, and they were published in prestigious journals, and nobody had a problem with them. But when I suggested that an object that passed near Earth in 2017 may have been artificial in origin, there was a huge backlash against that.
Yeah, they weren't happy with you.
Much less speculative. So I just don't understand. I mean, as far as I'm concerned, I follow the same practice.
Yeah, I think it's much more. I think the recent UAP report summarized it quite well, that there's a lot of social stigma against reporting those events, even if they are not extraterrestrial.
Yeah, but you would think that science should be immune from social bias. Science should pay attention to evidence, and when there is something anomalous, we should examine it. Dark matter is an anomaly that we want to explain. Why do people get so emotional about explaining something in terms of technological relic? And I should say, my suspicion is, people have no problem discussing microbes on Mars. Because we can still feel superior relative to them. Who cares? We are much more intelligent than these microbes on Mars. But if you find that there is a smarter kid on your block that produces equipment far more advanced than you possess, it's a strike against your ego. People have a problem with that.
Yeah, although I have a slightly optimistic idea that popped into my mind, which is the fact that if what we're seeing are probes of an advanced civilization, we still likely have hundreds or even thousands of years before that civilization might decide to reach us, because they must get the signal back.
Oh,
so
but the mistake you're making is that you think they need to come. Their agents can do all the work for them. They don't need to bring them. I mean, the agents, if they outsmart us, they can pretty much accomplish what they want. So the issue is really whether our AI systems can figure out their AI systems. And, sometimes when something looks innocent, it's not necessarily think about the Trojan horse story, and how the city of Troy in Greek mythology thought that the Trojan horse is, kind of cute. It ended up serving a very different purpose. And it was not, it didn't look like a military threat.
Mm-hmm. So I think we will circle back to the advanced civilizations before the end of the Q&A, but let's go back to the speculative front. And so there are rare particles that are observed that have extraordinarily high energy. I think the first one was called "Oh my God" particle, where a single particle can have 50 joules of energy, which is extraordinary for a particle. Do you know why we observe those things?
Several things. First, in natural environments, you can reach those energies. And for example, near the black holes at the centers of galaxies, these are the most likely sites where very strong magnetic fields and electric fields exist across large distances. And if you go through the numbers, they can produce such particles. Okay, and another environment is the jets that come out of galactic nuclei that produce very powerful radiation that we see. In principle, you can make it in exploding stars. We see gamma ray bursts. They could be the sites where some of these energies are achieved. One thing that I wanted to mention is the subject of a Scientific American article that I wrote last month, which talks about the possibility, if there is a civilization that decides to accelerate particles to the highest possible energy. It's called the Planck energy. In fact, if you use the best technologies we have, you would need an accelerator the size of the solar system to achieve that. But maybe some other civilization.
A linear one.
A linear one, yeah. So maybe some other civilization accomplishes that. The problem is that if you collide particles at the Planck energy, you could irritate the vacuum in a way that it could produce, could burn up this vacuum energy I was talking about before, and you will get a burning front propagating outwards at the speed of light. It's called the domain wall that could basically burn up the vacuum energy, the cosmological constant I was talking about, and burn up everything along its path. And you will never get a warning because it moves at the speed of light. So there is no signal that can reach you before this burning front reaches you. So I think if there are such civilizations, we should all sign a treaty about not creating a Planck collider, because if any of us manages to do the experiment, it may affect everyone else in the universe. So that would be the first treaty to sign. Never reach the Planck energy with your colliders.
The ultimate nuclear weapons treaty, so to speak. So going back to Earth, kind of, well, not necessarily, but some people wonder, does the Starlink project and similar projects that may launch like this, so basically swarms of satellites, will they hinder our exploration of space, or do we have any ways of working around those issues?
Right. I mean, it's not the exploration in terms of going to space, but more using telescopes. And in fact, I chaired the board on physics and astronomy of the National Academies for a few years. And that was a major concern when SpaceX announced the Starlink ambitions that it has, launching tens of thousands of communication satellites. Because in the original version, the way they sent it, those were highly reflective, and even at night they would reflect sunlight, just like the moon reflects sunlight, and they would become very bright. And as they cross the sky, they leave a streak on images of the sky. And for example, there is the Vera Rubin Observatory that will come into operation within a couple of years, and it would significantly compromise its ability to monitor the sky, because there will be, many of the satellites we would not get the coordinates of in advance. Some of them are spy satellites, some of them. So the problem is that the data would be compromised for astronomical purposes. And so we started a dialogue with SpaceX, and they promised, in fact, they painted one of the satellites as a test, black. So that can potentially reduce significantly the reflectance and make it tolerable. We can still see it even if it's black, but it's not, if it's not painted black, what happens, it saturates the CCD when you look at it on the sky, and then you get spillover. It's not just the pixels that it occupies. You get a much larger portion of the image, which is unfortunately compromised. So SpaceX hopefully will work with the astronomy community and paint those black enough that it will not be so much damaging to the future of astronomy. Of course, if there is no way out of that, we will have to go into space. If we will clutter our sky. It's just like putting, astronomical observatories in the past were always in remote locations because you don't want city lights to contaminate, light pollution of the sky to contaminate the observations. And now Starlink is putting city lights in the sky, so you cannot escape those. And that's very unfortunate for astronomy. I mean, it's something to be worried about. And I hope they will. I mean, it's another way to look at it is pollution of light, rather than if you think about pollution of the atmosphere with industrial chemicals, this is pollution of the sky with light that will prevent us from doing astronomical observations. And we should be worried about it.
Yeah, and I think there's also another danger in terms of just going to space at all, which is if we put enough trash on the orbits, it may not be possible to even get to space, right? And are we far away from that point?
No, I think the space trash is a major issue, which can be solved if you clean it up. I mean, that one thing I should say is that going through the numbers of those constellation Starlink communication satellites implies that, if we can see them with the Vera Rubin Observatory, we can also see UAP, all these unidentified objects that were reported to Congress. And we should be, hopefully we will be able to separate the two. I should say astronomers are focused on very distant sources of light that are not moving much on the sky. So for astronomers, all these nearby objects are a nuisance. Not for me, I should say, because in recent weeks, I became very interested in the UAP phenomenon. I would like to understand the nature of these objects that are unexplained in the scientific way by placing state-of-the-art cameras on wide-field telescopes that are monitoring the sky and providing more evidence. We don't need to rely on the government to tell us what is in the sky, because the sky is not classified. It's only the sensors that the government is using that are classified. So we don't need to go to ask Washington to surrender classified information. We can just collect it ourselves. And I should say that there were several very wealthy individuals that approached me over the past week in funding such a project.
Good.
So if anyone listening is interested, this is the time to join in, contact me.
Because my wife's brother is actually researching tracking satellites and space debris.
Okay, but if anyone is interested in funding such a project, a scientific project aimed at figuring out the nature of the unidentified aerial phenomena that were included in the report to Congress, then let me know. Because right now, it's not just one funder, I have several. And I'm planning to go ahead and establish a research project, scientific research project on that.
Nice.
We had a good question. Can we use Unleashed? We have a budget in X Team where people can use $2,500 a year to donate to causes that are things that are important to them, or unleash and grow in new ways. So yeah, maybe they'll be coming your way.
Okay, well, I'll be glad to hear about that. As I said, this happened in the last week, and you have to understand how unusual it is. I served as the chair of the astronomy department for 9 years at Harvard, and I'm quite familiar with attempts to raise funds for scientific projects. And usually what happens is people spend decades in convincing, having events and trying to convince people to give them money. In my case, I didn't do any of that. People approached me, okay? And that's very unusual. And it means that there is a great appeal to the subject. I can explain to you the rationale from my end, which is that currently most of the scientists are ridiculing this subject, if you listen to some people that are talking. They create an unhealthy situation where, on the one hand, people in Washington, D.C., these are mostly national security advisors and politicians and military personnel, they are talking about it as a serious matter. If you hear former CIA directors, Brennan and Woolsey, and former US President Barack Obama and others talking about it as a real serious matter. And the report itself mentioned that some of these are real objects. And if they are real objects, and we don't know their nature, there's only a limited number of possibilities. Either they're human-made. If they're human-made, well, some of them behave in ways that supersede our technological limits in the US. And so it will be a major failure of national intelligence if other nations are able to produce equipment that we cannot imagine. Okay, so that by itself would be a major piece of information, and I doubt it, because we pretty much know what other nations are able to accomplish. Okay, so if these are real objects and they behave in ways that we cannot explain with our technology in the US, then I would argue there are only two possibilities left. Either these are natural objects that nature produced, in which case they represent events or phenomena that we don't fully understand, we didn't expect, and or that they were manufactured by some extraterrestrial technological civilizations. And both of these possibilities are exciting. It's a win-win proposition to study them because we learn something new. And I think the subject needs to move away from the talking points of politicians or military personnel to the realm of science, because you wouldn't go to a shoemaker and ask the shoemaker to bake you a cake. For the same reason, you wouldn't go to a politician and ask a politician to explain to you something that has to be explained by scientists, and so it's very natural. But if scientists shy away from studying this, they would simply fuel speculation in the public. The public is very interested. So I think the best path forward is, rather than rely on what other people tell us, just get open data, collected with the best instruments we have, which are far better than the instruments that the pilots had on their airplanes, or the Navy people had on their ships, and collect it in an open way so that the analysis will be completely transparent, and then consider it a scientific experiment and just get the answer, clear up the fog, find what the nature of these objects is. And, we are in the 21st century. We are not in the dark ages where people have to believe miracles and have to have convictions about, or argue with each other, or that it's ridiculous what is happening. And I think we can just clear it up in a matter of years, figure out, whether these objects are indeed real. Science is about reproducibility of results. So if they are real, we will see them again. And we can get, all we need is a high resolution photograph. Just think about it. It's not a philosophical debate. If we had, for example, my book was dedicated to the first interstellar object that was discovered near Earth, Oumuamua. And I wrote a full book about it because it's sufficient to have one object that looks unusual, okay, in order to for it to have a huge impact on our thinking. And I wrote a full book about it. But if I had, they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. If we had a high resolution photograph of this object, and it would indicate that it's artificial in origin, I wouldn't need to write the book. So it's really simple. If you think about it, all we need is a high resolution photograph.
So this might have covered that, but just in case, what recent physics discovery or theory has excited you the most? Maybe are those
other than Oumuamua
satellite? Yes.
Maybe the image of a black hole, which was derived actually at the conference room of the Black Hole Initiative that I'm the founding director of at Harvard. Seeing just the silhouette of a black hole is something I predicted a decade earlier, and I was excited by. The discovery of gravitational waves is extremely exciting, because then you can see objects that collide and do not produce any light, such as two black holes coming together. And, that's for decades we've been looking at the sky using telescopes, looking for light that is emitted by sources of light. But now we have another messenger that can inform us about events at the edge of the universe, and that's gravitational waves. And it tells you about environments that are completely different than we have seen before, like two black holes colliding at the edge of the universe, and you're looking at the ripples in space and time. And so I would say these two are quite exciting. They're both related to black holes.
And also, quite a number of people were wondering what was the starting point in life in your interest in astronomy and physics?
I was born on a farm, as I said at the beginning, and I was mostly interested in philosophy, in the deepest questions, but then circumstances brought me into physics and astrophysics because I had to serve in the military. It's obligatory in Israel, and as a result, I regarded it always as an arranged marriage that I was not responsible for, and I felt bad about it. I always thought I'll go back to my true love, philosophy, but then eventually I was tenured at Harvard. At which point, I realized that in fact I'm married to my true love, because because there are some deep philosophical questions that we can address using the scientific method. And that's what makes me quite different than my colleagues, because I'm interested in the big picture. I'm open-minded to thinking outside the box. I'm not a nerd that is just curious about the technical details of solving some mathematical equation and just demonstrating that I'm smart. That's not really the issue. So in a way, it prepared me to be different. And also, the way I think about myself is that I'm no different than any other person who is not a scientist. You see, so I'm trying to explain only the things that I understand, and explaining them in a simple way, the way I understand them. And perhaps that's what made my book a bestseller, because when I get people, for example, a plumber coming to replace a pipe at home, and I can spend hours talking to anyone of any profession, and I don't, as far as I'm concerned, science is a way of life. It's the way you think about reality, and it's not a profession that elevates your status socially, like some of my colleagues believe.
Yeah, that's an amazing take, I think. So we have one last question.
Okay.
So do you see any conflict between belief in God and rational thinking? Do you think that religion should make way for science, or can they coexist peacefully?
No, I think they can coexist. I think that's a misconception, but the fundamental issue is, how do you define God? And I don't believe or I cannot see how an entity that cares about what each of us is doing could exist, and it would be sort of superior, because because we don't matter that much in the big picture. And out of modesty, it's not about us. Reality is very big, and for me, I'm struck with awe, and you can say this is sort of like a religious awe, but it's awe as a scientist, that the nature is organized by fundamental laws, the laws that we find in laboratory experiments. When I see my daughter's rooms in the morning, they're chaotic, they're not organized, and finding the universe, obeying the same laws of physics that we find here on Earth is amazing to me. I don't take it for granted. And to me, this organization is beautiful, and you can sort of admire. And it's sort of the sense of God that Spinoza, the philosopher, had, where nature itself is so amazing that you can admire it as a divine entity. And that's what I feel. But in general, what scientists do is, as if you are going to a building and you look at the bricks that make up the building and the way they are put together. So scientists are just trying to figure out how the bricks are put together, but they are not thinking about the blueprint. Why is the building constructed this way? That is metaphysics. Thinking about why the laws of physics have their current structure, and I think religion can thrive in that domain of metaphysics, things that go beyond the way that the universe operates. Okay. And the mistake made in some instances in the past was when religion tried to make a statement about the physical world, the way it works, like the sun moves around the earth. That's a wrong step to take, because it's up to data, evidence collected by scientists to figure whether the sun moves around the earth or the earth moves around the sun. But if you're trying to understand why is the universe the way it is, going beyond the physics, that could be the realm of religion and theological beliefs, and they could coexist with science. I don't see a conflict. The last point I wanted to make is that a very advanced civilization that develops a very advanced technology, could appear to us as an approximation to God. What we assigned to God in the past was ability to create life, ability to create the universe. A sufficiently advanced technology might be able to create life, might be able to create baby universes. So to us, it would appear as an approximation to God. And that's the last statement.
Great answer.
Yeah, it's amazing. Eric, as a kind of tongue-in-cheek, Eric wonders if we had the technology, we could inject some mass into Pluto, so it's back to being a planet.
Yeah, actually, this is called terraforming, that you can take a planet that has no life on it and change, sort of restructure, just like going to an old house and you want to make it livable. Okay, so that is a major engineering project that in principle can be taken, and people talked about it in the context of Mars. But it takes a lot of work and money.
We'll see. Maybe we get funding for that as well.
Well, that's the next step. First, let's figure out, maybe if we are not alone, if there is a smarter kid on the block, let's figure this out first, because they might have the solutions to many problems we have.
Yes. Well, I think if China was late to the Mars race, it's unlikely they have this amazing spacecraft flying around our oceans.
I would argue that as well. That's why I want to figure out these objects. To me, it's what I find really frustrating or surprising is that many scientists would ridicule this subject. But if you look at the history of science, when discoveries, major advances in our understanding of reality or of nature came out of anomalies, things that didn't quite line up with what we expected. Quantum mechanics is an example. A century ago, nobody expected it. It's still a bone in the throat of physicists. We don't understand really the fundamental, underpinning of quantum mechanics. What does it mean? And so, but all the devices that we have, that we use to communicate with each other right now, the computers, the speaker, everything, it's based on quantum mechanics, and we can use it. So my point is, we should allow for ourselves to be surprised. If Twitter existed a century ago, I'm sure that this subject of quantum mechanics would have been ridiculed. Just like, Galileo, instead of being put in house arrest, would have been canceled on social media.
Yep. Yeah. And the other thing I find interesting about UAPs, it's not helping the American ego that we have, is that they only seem to fly, they only care about Americans, apparently. They only want to hang out in our oceans.
That may be a selection effect, that other nations are occupied with other matters that are not sensitive as much. And, like, for example, if you go to the Middle East, there are so many things going around that you wouldn't notice the signal from the noise. You might say, that's, who knows? But it may well be that we don't know what kind of information it's seeking, and it may well be that it's seeking information about some specific technologies that the US possesses. It's really strange that indeed the reports are mostly coming from military facilities. And it may well be that we simply patrol these facilities more often, and that's why we see those objects. Or there is some particular interest for this. But irrespective, we should figure out what these objects are. If at the very least, we need to protect our airspace. If something enters your home, you want to know what it is. Irrespective of whether it's human-made, not human-made, just let's first get a close-up image of it.
Exactly. Well, speaking of extraterrestrials, again, I want to pop up your book here, Extraterrestrial: The First Sign of Intelligent Life Beyond Earth. Definitely check out that book. If you're an X-teamer, you can get it using that Unleash budget we talked about earlier. But again, we've reached our hour, so thank you, Dr. Loeb, so much for this talk. It was absolutely enlightening.
Well, thank you for the excellent questions. I really enjoyed it. And just to say, I wrote this book primarily to young people, so that they would, they are not confined by prejudice or their ego as much as the more senior people. And I hope that the intellectual culture will change in the future, will be better than the past.
Well, I've always appreciated how you are always speculative for fun sometimes, but also also critical of making sure we do this properly as scientists. So I've always appreciated your opinions. And actually, if you want to follow Dr. Loeb's opinions, we will post a link with this video to your Harvard address, where you have many, many amazing opinions to check out. But
yeah,
again,
every week I publish.
Every week. Wow.
In Scientific American. So there is a section on my website that is opinion essays. Just check this out and you'll find the latest.
Yeah, we'll put it in the chat right now, actually. And yeah, again, thank you so much. And I hope we get to see you again someday.
I'll be delighted. It was a pleasure.
Great. And thank you as well, Michal, for moderating.
It was a pleasure.
We will see you in an hour for Trivia Dungeon, the end of STARCON. And again, thank you all. Take care.